Cass, can you hear me?
Oh, hi there.
Hello.
Sorry about that. We're going to go ahead and get started with our webinar today. Thanks so much for joining us. My name is Cass Hardy. I'm a team member of the Connected Conservation Community of Practice for the National Park Service. We're an interdisciplinary group that focuses on cross-boundary work with the national parks, as well as all of our external partners. Today we have a great webinar with John Beckman. Before we get to that topic, just a couple of quick things. I'm going to plug a couple of links into our chat box there, where you can learn more about our Connected Conservation Community of Practice, as well as take a look at some of the resources that we provide through our community's work. One is an internal link to all Department of Interior employees that is packed with resources that focus on policies that enable us to do this type of work, as well as our entire webinar series in a recorded fashion. In addition to that, we'll also plug in a link that goes to an external site with the Network for Landscape Conservation that'll allow all of our partners and friends groups or others who are interested in connected conservation to see similar resources, including an online playlist through YouTube that hosts all of our webinars to date. So folks can take a look at that. We're always open to topic ideas, so feel free to plug a topic in the question box or in the chat box, or you can always email us with ideas of topics that we could highlight. With that said, we'll have about a 35-40 minute presentation, and we'll open it up to questions at the end. John, thanks so much for joining us. John Beckman is the Science Director at Rocky Mountain West Program with the Wildlife Conservation Society, and we're really looking forward to this presentation today. So go ahead, John.
Thank you, Cass. And thank you to everyone that's joining the webinar. I will start by acknowledging several of my colleagues at WCS that were instrumental in a lot of the data collection and conservation actions that resulted from those data, particularly Dr. Joel Berger, Dr. Kim Murray, and Renee Seidler. And we had a host of other partners that were instrumental in this work, and I will highlight them and acknowledge them throughout the presentation and at the end as well. I also want to acknowledge our funding sources and cooperators, specifically the National Fish and Wildlife Foundation. Shell, Ultra, and Questar were important in our winter range work and the impact of natural gas development on pronghorn. And then I especially want to thank Grand Teton National Park, specifically Steve Kane and Sarah Dewey. Steve in particular was instrumental in working with Joel and others at WCS to get some of the conservation done that I'll talk about today. And then I also want to acknowledge Wyoming Game and Fish Department and the Bureau of Land Management. So for today, I have several goals. First, I want to talk about long distance migration, focusing on terrestrial ungulates, although there's a lot of different taxa and species that undergo long distance migration. But for today, I'll focus on terrestrial mammals. And I want to put this a little bit in a global context before focusing more on a more local context. And I'll focus on one particular migration that we focused on out of many that we studied for pronghorn in western Wyoming in the southern part of the Greater Yellowstone ecosystem. And that's the migration that became protected as the path of the pronghorn between their summer range in and around Grand Teton National Park and the winter range in the Upper Green River Basin. And I'll use this particular migration to look at some of the attributes and threats to that migration, to use it as a case study. And I'll spend a little bit of time talking about the different aspects of protecting this migration and some of the impacts of habitat fragmentation from natural gas field development on crucial winter range, and the concerns that are occurring on winter range to maintaining this long distance migration. I'll talk about our study approach, some results, and then I'll talk about the application of the lessons that we learned from the path of the pronghorn to other parts of the GYE and other species. And I'll just spend about 5 or 6 minutes on that aspect before wrapping up with some conclusions. So to set the context, when we look at migration and dispersal and the need for habitat connectivity, And if we ask the question, are biological corridors relevant in some places across the globe, but here in North America, I think the answer is a resounding yes. What you can see in these series of images is the increasing human footprint, particularly not only in the eastern part of North America, but an increasing human footprint in the west. And that's being demonstrated by an increase in housing density and housing growth, particularly in the valley bottoms, in between public lands in the Intermountain West. And for about the last 40 or so years, in the upper left here, you can see the census data. Most of the fastest growing counties in terms of rate of growth occur in the western part of the United States and North America. One of the things we know is that long distance migration is an imperiled ecological phenomenon. It's disappearing across the globe, and it depends on the species and the region of the globe that you're talking about for the decline of long distance migration, but it falls into the causes of loss fall into three major categories. One is overuse of the wildlife resource, which doesn't occur as much in North America as it once did. But other causes are things like anthropogenic barriers, things such as roads, and then of course habitat loss and fragmentation. And that can be from things like exurban sprawl or natural resource extraction. But what we really need in a lot of cases is those data to quantify where impediments or threats occur to maintaining long distance migration in order to have data-driven targeted mitigation. So just to put this in perspective, when we look at where overland migrations remain on the globe, we find long distance migrating mammals occurring on most continents. There's a bias in the data towards North America due to the amount of research that's been done here. And there's a lot of different species, some that are well known and some that aren't as well known, that make long distance migrations. Obviously, we have world famous wildebeest that everybody's familiar with. Various populations of zebras. We have species like Asian gazelles and chiru in places like the Tibetan Plateau. But there's other species that may not be as well known. Obviously, elephants are well known, but things like hulans in the Gobi Desert or waymal, which is a higher elevation deer that occurs in South America, make long distance migrations. Here closer to home, we have many species that migrate, including world champion migrators like barren ground caribou, but species like muskox, moose, and bighorn sheep all migrate. And then in places like the Greater Yellowstone ecosystem, we have world famous migrations, such as the elk migration that occurs down to the National Elk Refuge in the Jackson Hole region. When we look at the Western Hemisphere and data for the mean round trip distances in kilometers, and the means are shown here in the boxes. And so again, these are Western Hemisphere species, so African and Asian species have been eliminated, and these are subarctic species, so we have eliminated Arctic species. And these data come from Joel Berger and others in a paper published in 2006. But what you can see is for 5 of the species, the longest known migration occurs in the Greater Yellowstone ecosystem. So for moose, bison, mule deer, elk, and then pronghorn, the longest known migration occurs in the GYE, and the tails show the outline of the longest migration. And so the one I'm going to focus on today is this pronghorn migration that occurs between the Upper Green River Basin and the Jackson Hole Grand Teton National Park region. So if we ask the question, how important is connectivity, and we use pronghorn as a model species, one of the things that we know is for a species like pronghorn that don't deal with deep snow very well, it's really critical that they can move between discrete summer and winter ranges, particularly in places in the Intermountain West where we can have severe winters, such as we find in the Greater Yellowstone ecosystem. When we look at the known recent migrations, in the Greater Yellowstone ecosystem of pronghorn over the last several decades, one of the things that we've seen is we've lost 75% of those known migrations. Most of those have been lost due to habitat conversion from things like agriculture and other anthropogenic barriers such as roads or fencing. And we're left with really only 2 long distance migrations shown in the black arrows. And this one in the north in the Madison River Valley of Montana is tenuous at best because of some exurban sprawl and ranchettes and subdivisions going in at the southern end of this migration. And so we're really only left with one intact, healthy migration of pronghorn in the GYE, and that's this migration that occurs between the summer range in and around Grand Teton National Park and the winter range about 120 kilometers away in the Upper Green River Basin near the town of Pinedale, Wyoming. So in 2003, again, Steve Kane with the National Park Service and Grand Teton National Park and Joel Berger and others at WCS, we began looking at this migration to try to define it. And one of the things that we've seen is that collaring over 50 animals that summer in Grand Teton National Park between 2003 and 2012, I've only put 10 of those animals on this particular map so you can see it. This route is very tightly defined and it's invariant. And that's due to the topography and the geography of this region where the animals are having to cross over the Gros Blanc Mountains in their spring and fall migrations in and out of Grand Teton National Park. And this is demonstrated nicely by this female here in blue. In the spring migration returning to summer range, she tried to go through the Hoback River Canyon area, which historically was a migration corridor in this system, but it's since been severed due to the highway and other human activities in that region. And so she came all the way back around, joined the migration, and returned into Grand Teton National Park. And so it was really nice to see the animals and looking through their eyes define their critical pathways. And once we had those data in hand, then we could define the migration corridor, and those data allowed us to then move to protecting this corridor in a more formal way. Now, there's various options to sustain migration and habitat connectivity, and here we wanted to protect the corridor more formally, but the question was, how do we do this? You know, we wanted to be a little bit more bottom up as opposed to top down, but we knew that data had to be the starting point. And even though it's just the starting point, it has to be that foundation to have these discussions. And then we knew we had to engage diverse communities and stakeholders and decision makers in order to make this occur. So again, the data that was generated by WCS and the National Park Service started the conversation. And then we initiated this effort with help from partners after meeting several times with then Governor of Wyoming, Dave Friedenthal, to gain advice and support. And we formed a large group of stakeholders that started to meet with legislators on Capitol Hill. And to make the path of the pronghorn a reality, a group of ranchers, cattlemen, outdoor recreationists, hunting enthusiasts, and state and federal officials all collaborated on a conservation plan that later turned into this federal designation. And really the paramount important imperative was respect. And that was listening to people with various views and understanding their perspectives to gain their support, but also communicating the science clearly. And what happened as a result of this in 2008, we had the designation of the first federal migration corridor in U.S. history, and that was the path of the pronghorn. And a little bit of a commentary here, we're 10 years past that, and to date, this is still the only federally designated migration corridor. And so we think this can serve as a model of how we may be able to achieve similar outcomes in other areas. In addition to the fact that the migration corridor was well defined and invariant, it was also nice that in this case, 95% of the land that the pronghorn were traversing was already under federal management. So that lent itself well to protecting this corridor. I want to spend a little bit of time just talking about the corridor itself. And so I've got the corridor mapped here. And what you can see is that in the upper left is the summer range, the Teton range here, Grand Teton National Park region where the summer range is, and then the winter range down here in the upper green. There's three major bottlenecks along this migration path moving from the north to the south. The Red Hills bottleneck is not much of a concern. It's just a region where the animals almost look like bighorn sheep or mountain goats as they traverse the side of this mountain above the river. The next bottleneck coming south is a little bit more of a concern. We call this area the funnel. This is the area along the migration corridor where we have more private lands. And so because of the designation of the path of the pronghorn, we saw many groups such as Land Trust working with private landowners to get conservation easements and fence modifications on the landscape in this region. And then the most concerning bottleneck is the Trappers Point one in the south, and it's the most famous one. And the point is that if we sever this migration corridor, any one of these bottlenecks, then we lose pronghorn as a species from Grand Teton National Park. And so that's obviously not the mandate of the National Park Service, and that is a concern. And so the long-term persistence of a megafauna species, in this case pronghorn, in a national park is going to be predicated on what happens in the migration corridor and on winter range. If we look at the zooming into the Trappers Point bottleneck, you'll see that this is a natural bottleneck. It sets here between two riparian areas, the New Fork River and the Green River. Historically, it was about 1 kilometer wide, but due to some subdivisions, it's now down to about 0.5 kilometer in width. And so it's already smaller. In addition, one of the concerns here is you see the solid black line that I'm highlighting here with my pointer. This is US Highway 191, and it transects the migration corridor right in the middle of this bottleneck. And so there was a recognition by the state of Wyoming and the Wyoming Transportation Department that this road could potentially be having impacts. And indeed it was. There was a fairly high number of wildlife vehicle collisions between pronghorn and mule deer in this region. And because of the designation of the path of the pronghorn and that elevating the focus on this migration corridor, in about 2007 or 8, the Wyoming Department of Transportation began getting data from WCS on pronghorn and other groups on mule deer in order to mitigate this roadway. And in 2010, 11, and 12, they began construction of $9.7 million in crossing structures. So 2 overpass structures and 6 underpass structures for pronghorn and mule deer along a 13-mile stretch of Highway 191. And one of those crossing structures set right in the Trappers Point bottleneck, and that's this picture here. This is a photo of pronghorn using the crossing structure for the first time after its completion in the fall of 2012 on their migration back to the winter range to the south. And we published a paper this year where we looked at the behavioral and movement response of the pronghorn during 3 phases of this construction, pre-construction, during construction, post-construction, to examine the effectiveness of this. And I will say that these have been highly successful. We've reduced wildlife vehicle collisions by more than 85% based on some data from West Inc. And the Wyoming Department of Transportation since these crossing structures went in. One of the things that we wanted to do is scale up from the path of the pronghorn. And so you'll recall that we had met early on with then Governor Dave Friedenthal at Wyoming. And when he was in charge of the initiatives for the Western Governors Association, he proposed the Crucial Habitat and Wildlife Corridors Initiative that ended up being the WGA's Policy Resolution 10.10. And what this led to was the creation of the Crucial Habitat Assessment Tool, or the CHAP process, for the 17 Western states. And myself and Keith Ani from WCS and others sat as a science advisor to the WGA during the CHAP process. And people can debate the relative quality and the going forward and the initial quality of these individual state chats and the West-wide chat and the politics and policies that went into them. But we think it was a really good example of scaling up to a much larger regional level. And these chats weren't really, they're not a regulatory tool, they're really a decision support tool. And so if somebody has a project that they're proposing, they can overlay their shape files on the chat, and then they can get information of what species or what critical corridors are in those areas. And then they also can get the contact information and which agency to contact in order to understand what some of the wildlife resource issues are in that area. So some of the lessons that we've learned in protecting the path of the pronghorn is, first, in order to protect migration on the landscape, we have to be concerned with all 3 components. In the case of the path of the pronghorn, the summer range is well protected in Grand Teton National Park and the surrounding Bridger Teton National Forest areas. But as we know, parks and protected areas are not large enough on their own, and particularly for an ecological phenomena like long distance migration, what's happening outside of park boundaries is going to be really important to the long-term persistence of pronghorn inside the park. In the second component, the corridor itself, it's partially protected. The Bridger Teton National Forest designation of the path of the pronghorn protected the northern 70% of the migration corridor, but they're still concerned in the southern about 30% of the corridor because it occurs on BLM land where there's a lot of natural gas development occurring. Now, the BLM did place some area of critical environmental concerns, ACACs, in the Trappers Point bottleneck specifically. That's very helpful to maintaining this migration. And then, of course, the state of Wyoming with their investment in the overpass and underpass structures along this migration. But what I want to speak about for a few minutes here is the third component of this, and that's the winter range, which currently is fairly vulnerable for a species like pronghorn. So just to help orient you, this is the winter range that occurs mainly on Bureau land management lands in the Upper Green River Basin outside the town of Pinedale, Wyoming, which you can see sits about here. And again, we're about 121 kilometers south of Grand Teton National Park. Now, the Upper Green has world-class wildlife. It has abundant wildlife. We have an estimate at one time over 100,000 overwintering ungulates, pronghorn, elk, mule deer, and even some moose. And those are Serengeti-like concentrations. And so this is world-class wildlife populations in this region. And it's also a stronghold for species like sage grouse in this area. But we also have abundant gas reserves. There's an estimated 30 to 50 trillion cubic feet of natural gas in this area. Two of the largest natural gas fields in the North American continent set here, the Pinedale Anticline Project area, known as the Papa, and the Jonah fields. And because this gas is on average about 13,000 feet into the ground, the infrastructure to extract those resources is pretty substantial. And you can see in this fairly dated photograph, this leads to a tremendous amount of habitat alteration and fragmentation on the landscape from well pads and roads. Just to help orient you, again, we're in western Wyoming. The town of Pinedale's here. The Papa sits here. It's a much larger gas field in spatial extent than the Jonah, but it's not as heavily developed with the infield process as the Jonah field. There's also a current process to expand the Jonah field by about 2.5 times to the west and to the south in a gas field that's known as the NPL, or the normally pressured lands region. So what we wanted to do was assess the potential effects of gas field development on pronghorn use and on winter range. And as you can see from satellite imagery, habitat change has been rapid and pretty substantial over the last 25 years or so. And the question is, why might gas field infrastructure affect wildlife? Well, this is just simply through the idea of carrying capacity. There's a lot of different ways to define carrying capacity, but for the purposes of today, I'm just going to define it as the concept that a given habitat can support a finite number of animals without deteriorating. But we know this is a moving target from year to year, from things like precipitation or perturbations and disturbances such as fire. But generally, we know if we decrease either the amount or the quality of habitat, we have fewer animals. Now, gas field infrastructure can affect wildlife through direct habitat loss at well pads and roads, but it can also lead to indirect habitat loss due to behavioral avoidance. And so if noise or human activities on roads or well pads permeates out into what would otherwise be a suitable habitat, then you could actually have a larger impact from the human footprint than just the physical structures themselves. And of course, infrastructure can lead to deaths from injuries from things like roadkills or fencing. In the lower left here, you'll see an example. In January 2007, we had 20 pronghorn killed in a single collision with a single gas truck in the Jonah field. And so it can be fairly substantial impacts at times. And gas field infrastructure can also affect wildlife through energetic cost of disturbance. If animals are spending more time being vigilant, particularly in places like the Upper Green, where pronghorn are overwintering at 7,000 feet, they're already on a sliding body mass scale throughout the winter. They're not maintaining body mass, they're already losing it. If they spend more time being vigilant or running, if they don't habituate from disturbance, then that could speed up that rate of decline, which could ultimately lead to lower fecundity and demographic impacts and survival. Gas field infrastructure could also potentially introduce diseases or lead to exposure to toxic substances in the environment or increase stress levels, all of which could reduce survival of fecundity. Now, the extent of the effects is going to be determined by proximity to carrying capacity. In the Upper Green River Basin, pronghorn in our 4,000 square kilometer study area, pronghorn are hunted with an average removal over the last 10 years of about 2,200 animals per year. And so if animals are held below carrying capacity, that could mask some of the impacts. But yet if we do see impacts from development, then it may mean that those are fairly substantial. The extent of effects is also going to be determined by the amount of habitat loss and the extent to which animals rely on impacted areas. Okay, just a little bit more information before I go into the study design. Again, the PAPA is about 198,000 acres. Currently, there's about 6% or 11,000 acres being disturbed. But in 2007, they created a supplemental EIS that created these development areas, and they're labeled 1 through 5 from north to south. And in these proposed developed areas, the proposed disturbance could be up to 40% of those areas. And so there's extensive habitat alteration over the 25-year life of this project. And I just wanted to give you some idea of how important some of these DAs are, particularly DA2 here in the green and 3 in the blue along the New Fork River. These overlie, these DAs are concurrent with areas that the Wyoming Game and Fish has delineated as crucial winter range for pronghorn for over 50 years. And so these are some data just from 1 year, and you'll see as it moves through time. In January, you see heavy reliance on these. February, the animals are relying heavily on these DAs. March, by April, animals are starting to migrate back to their summer range, and then again the following October, they're back during the winter. And so the development in these two DAs could have disproportional impacts on pronghorn in the region. So in order to examine the impacts of gas fields, we did a comparative study. We looked at females in both experimental areas, which were in overwintering in gas fields, and compared those to females in control sites. We captured pronghorn with net guns fired from helicopters. We took standard morphological measurements. We also took fecal and blood and serum samples, and then we weighed each individual. And we placed a GPS collar on each individual female that collected up to 8 locations per day. This is just a breakdown of the capture locations of 400 pronghorn that we collared since 2005. These circles represent experimental animals captured inside the gas fields, and the squares represent control animals captured away from the gas fields. One of the things that's nice is that even though pronghorn are highly mobile on the landscape and fairly nomadic in their movements during winter, they do have very high site fidelity within and across winters to winter range. And so it was relatively easy to classify animals as control or experimental. This is the winter of 05 data. Just I could have picked any year, but just to be an example, you can see our experimental animals remained inside the gas field boundaries the entire winter, and our control animals here on the right were outside of the gas field boundaries. So what we did is take a holistic approach to looking at the impacts to pronghorn. And so we compared levels of disease exposure and exposure to toxic substances such as PCBs or organophosphates between control and experimental animals. We looked at stress levels, looking at fecal glucocorticosteroids. We used fecal as opposed to serum levels because that's a better measure of chronic stress levels and longer term windows as opposed to serum levels, which would be elevated, particularly capturing animals from helicopters. We also modeled survival and looked at body condition. We estimated annual survival rates in program MARC, which I'll talk about here in a second. We looked at pregnancy rates using fecal and serum progesterone, and again, compare body mass between females in gas fields and not. And then we also wanted to know about pronghorn distribution and resource selection during the winter, looking at factors such as habitat loss, levels of fragmentation by well pads and roads. And then we had to control for snow depth because we know that snow has an overriding influence on pronghorn distribution during the winter. So we had to account for that in our models. And then we also had some measures of human activity such as traffic volume. So to some results, the good news for pronghorn in the system is that for disease in our eco-tox surveys, these were all below minimum detectable levels. So we saw no evidence of disease or exposure to harmful chemicals in the gas fields compared to females in control areas. In this graph and in subsequent ones, our control animals will be in the clear bars, our experimental animals will be in the dark shades. And what you can see for stress levels, looking at mean fecal corticosteroid levels, is that we did not see any difference between control and experimental animals, although we did see differences across years. For example, in 2007, a harsh winter, we saw elevated stress levels. And pronghorn in this region had elevated stress levels compared to pseudo-controls of pronghorn in the Pocatello Zoo and the National Bison Range in Montana, which is not surprising given that they're overwintering at about 7,000 feet. To look at differences in survival, we use monthly telemetry flights. We use program marking using known fate models. We allowed models to vary by site, year, and body mass, and also seasonally within years. And again, we saw no differences in annual survival between control and experimental animals, but we did see variance across years and within a year. Our annual survival estimates were lower during the fall, during the hunting season, compared to other times of the year, not surprising. Same with our pregnancy rates. Using fecal progesterone, we did not see any differences. I'm just showing about 3 years on each of these graphs because by the time I put 6 or 7 years on here, it can get really crowded and difficult to interpret. And as well for body mass, we saw no differences between females in control areas versus those that were experimental animals using the gas fields. And so really the take-home message is we did not see any demographic effects. However, one of the things we saw was a big shift in the distribution and resource selection of pronghorn during the winter. And so to examine this, we used mixed effects resource selection function models. The reason we use mixed effects models is because we needed to account for the variation across individuals and their level of habituation. And so we included those random effects for individual pronghorn. And we modeled resource selection using those typical factors that you see in RSF, including things like elevation, slope, aspect. But we also had vegetation type, well pad status, whether it was an active well or if it was in production or development phase because of different levels of human activity. And then we looked at things like distance to nearest road and well pad, and then habitat loss, which was based on the percentage of disturbance in a 300 meter by 300 meter grid. And you can read all this in a paper we published in 2012. But the take-home message of this, if we look at the resulting models mapped out, higher probability of uses in the dark blue, lower probability in gray. What we saw is an abandonment by pronghorn of crucial winter range over time due to development and habitat fragmentation. And you can see this in the Jonah field, and if we extend this out, our models for multiple years, you'll start to see it in the spine of the Papa as well, where the development is heaviest in the DAs. In fact, what we saw is the percent of patches identified as very high use dropped by over 5-fold during a 5-year period from 05 to 09. And so we're starting to see a behavioral response to pronghorn that has yet to translate into a demographic response. Now, of course, the effects are not going to be uniform. You can see here, these are 5 years worth of data. The control animals in green, they are not using the gas fields, so they're not going to have as big an impact as the experimental animals in the blue and the yellow. The yellow are just the animals that use the path of the pronghorn that summer in Grand Teton National Park. And I'll just make the point that of all 50 animals that we've collared inside Grand Teton National Park, all of them overwinter inside the gas field boundaries. And so what's happening on winter range could potentially impact the long-term persistence of this population. I'll just make a quick point of accounting for individual variation. This is a female 953 in the winter of 2006. Her locations are in yellow. The gas well pads are in red. You can see she showed apparent avoidance of the most densely developed part of the gas fields. In the same winter, female 902, shown here in green, did not show the same levels of avoidance. And so our models did perform much better when we accounted for that individual variation. So the last thing I want to talk about is the concept of stopovers on winter range and during migration. And this comes from avian literature. Matt Kaufman and others at the Wyoming Cooperative Unit applied this to the idea of mammal migrations. And what they saw is that these high probability areas were being driven by resource quality. However, what we were seeing when we were modeling the movement of pronghorn during the migration, so this is a movement of pronghorn moving north, you can see as they came to Highway 191, we saw some of these stopovers may be occurring where there was a hazard or a barrier. And so we wanted to see, are these stopovers and high probability of use areas really driven only by resources, or could they be driven by impediment? And to do this, we built Brownian bridge movement models, which just takes the probability from Brownian motion variance. And it's an empirical estimate of the movement path using both the distance and the time between locations. So here on the right, you see locations of an animal as it's moving, and then we produce a maximum likelihood that results in a utilization distribution for the animal's path. And we took those utilization distributions and we plugged them into a resource utilization function. And this RUF is basically a resource selection model, except that it relies on those utilization distributions from the Brownian bridge as a continuous response variable as opposed to a categorical variable of use versus available. And what we wanted to do is we wanted to model if roads and gas well paths could be a driver of these stopover points in addition to just resources. And so we looked at side of highway, so whether it was the approach side or the departure side as an interactive term. And then we looked at things like distance to road, shrub habitat, and then NDVI as a measure of habitat quality to disentangle that. And the short version is in places like Highway 191, so this is a spring migration here on the right, so animals are moving north. This is the highway here. Trappers Point bottleneck is here. This is 2006, so this is prior to the road mitigation structures. What we saw is these hotspots or these stopovers. And just to give the take-home message of a paper we published in 2014, along Highway 191, where we had a high level of traffic and non-wildlife friendly fencing, we found that the stopover points were actually being driven by the impediments and not just resources. In contrast, in other places like Highway 191 or 189, where we had lower density traffic and wildlife friendly fences, just summarizing quickly here, we saw that these stopover areas were being driven by resources and not the impediment. And so we saw the same pattern in the gas fields, and what we've seen over time is that the gas fields are altering these stopover points in the migration corridors themselves as animals over time are avoiding the most densely developed areas, not just during the winter, but along their migration routes as well. And so that's a caution that we make to just keep an eye on this as we monitor it going forward. I'm going to spend like 2 minutes going into one other thing. So this isn't a breadth shift, but one of the things we wanted to do is, again, take the lessons we learned from the path of the pronghorn and apply them to other places. And so one area we're doing this in is the western part of the GYE, where we're looking at long distance movements by moose and elk that used the Henry's Fork caldera during the summer near the town of Island Park, just west of Yellowstone National Park, which sits right here. And some of these animals, these moose and elk, also use the southwest corner of Yellowstone National Park as well. And they make a long distance migration to the Upper Snake River Plain near the town of St. Anthony. And these elk and moose are migrating about 50 to 70 kilometers, and this migration is being bisected by US20 And there's a high level of wildlife vehicle collisions. In fact, between 1982 and 2012, over a 30-year period, this one road in the state of Idaho represented 23% of all wildlife vehicle collisions in the entire state. So I'm going to go through this fairly quick, but WCS partnered with Idaho Fish and Game and the Idaho Transportation Department, and we collared 37 elk and 42 moose, and we used techniques very similar to what we just did for pronghorn. And we identified the crossing locations and the high probability crossing locations for elk, as you see here on the left. The higher probability crossings are in red. Migratory moose in the center, and non-migratory moose or year-round residents here on the right. And one of the things that we found is that even within a species, so for moose, the differing life history traits led to different selection patterns of crossing the roadway. And so this becomes a big challenge when we think about mitigating the impacts of things like roads for long distance migrating species, because the different life history traits, whether they're year-round residents or the migratory segment, can lead to very different answers on where you would target your mitigation. And so this led to a complex challenge along US20 because it highlighted a long stretch of this road as a high probability of crossing between elk and the two different subsets of the moose population. So what we've learned is that this can be very complex, and we are using this information in a way similar to what we did in Wyoming to get crossing structures placed there. ITD is now using this information to plan mitigation concurrent with highway improvement projects, which will increase their efficiency and cost effectiveness. And we're to the point now, after having the data in hand, that a larger scope of partners are being consulted, and partners are having things like meetings and workshops and taking comment periods in the environmental assessment to determine how best to mitigate this road and where. And obviously mitigation is complex and includes a lot of different considerations of things like topography and ecology and engineering and land ownership. And there's a lot of different options to mitigate. And so these are long, drawn out, complex processes, but all the different groups and different agencies need to be involved. So in conclusion, what we learned is that in order to protect functional and structural connectivity across political boundaries, in the case of something like Path of the Pronghorn, all land and wildlife management agencies have to be participatory. For the long-term persistence of pronghorn, what's going to occur on their winter range and the migration route could have a direct influence on whether pronghorn are maintained into the future in Grand Teton National Park. And as is the case, a lot of times the protection or enhancement of connectivity is only as strong as the weakest link. And we learned that by having a holistic approach and having behavioral components to our study, we saw behavioral impacts prior to demographic impacts. And so we recommend that behavior may be a better sentinel in some situations compared to demographic studies alone. And finally, you know, what we learned is that you have to be concerned again with all three components: the summer range, the migration corridor, and the winter range. And in the case of the Path of the Pronghorn, we still see the winter range being extremely vulnerable. With that, I want to acknowledge all the people that were involved in the Idaho project. I know I glossed over that, but I just wanted to make the point that, you know, lessons that we learned from Path of the Pronghorn are transferable to other areas. And so I want to acknowledge Mark Hurley and Tim Kramer, Shane Roberts, and Scott Bergen at Idaho Fish and Game and ITD. And then I also want to acknowledge all the various folks that played a big role in the pronghorn work in Wyoming. And with that, I will end by thanking Quicksilver Air for the many hours of safe flights in the helicopter while we were doing the capture work. And I'll thank each of you for taking part in the webinar today. And if there's time, I would gladly answer any questions if there are any. Thank you.
Thank you so much, John, for that very inspiring webinar that you just shared with us. Incredible amount of work that has gone into this project, obviously. At this time, we will take questions. You're welcome to drop a question in the question box in your GoToWebinar panel there. We'll also open up the lines and allow folks to ask questions aloud as well. So if you know that you're going to be in a noisy area, feel free to go ahead and mute yourself. And it sounds like we have a number of people who are in noisy areas. Feel free to drop your questions in the question box, though, if you do have some. If somebody wants to try to get us started. Geneva, it looks like you had your hand up. Do you have a question to get us started?
I just tried to type it.
Yep, go ahead.
Can you hear me?
Yep, we can hear you. Go ahead.
Oh, sorry. So I just the normally pressurized Lance record of decision is out, so it will be impacting all the different species that use sagebrush in that area. So I don't know if that's. I guess my question is, I guess that's new information finalized at this point. If you have any comment.
Yeah, that was really hard to hear what the question was there. I heard something about the normally pressured Lance area, but I'm not sure what the question was.
It looks like the question that she typed. The question that she had typed in the box is, have you seen the recent release of the NPL rod?
Yeah, we've seen that it was recently released, and you know, I haven't sat down honestly and gone through that yet, but we do know that the groups that were brought in by the BLM, the consulting groups to compile information and data, did take a lot of our pronghorn information and data and Brownian bridge movement models for migration and other aspects to at least look at. I have not seen the final decision that just came out recently to see how well those were incorporated, but I will be curious to see that, and I hope that answers the question. I'm not sure because I couldn't hear.
And I'm going to keep everyone muted because it seems like everyone's kind of in a noisy area. She said, thank you. That is good. Perfect. Any other questions, feel free to go ahead and type them in the question box there. We'll just give it a few minutes to let people type it in. Again, we will leave everyone on mute just because of the amount of feedback we had with that, that initial response.
And I'm not sure if there's a way that I can see it.
Yep.
Okay, go ahead.
Another question here, John. Is the county at Trappers Point revising their zoning development pressure?
You know, to be honest with you, I'm not as familiar with what the county is doing specifically at Trappers Point. I know that there is where the BLM put the areas of critical environmental concern were very key to that Trappers Point bottleneck. There's a kind of a checkerboard, as we see a lot of places in the West, of public and private lands there. But the BLM lands right now seem to be where the vast majority of the pronghorn had been going previously. And so that's one of the reasons why I think today, even though the bottleneck there has been shrunk from a historically kilometer wide area to about half a kilometer, the migration has continued uninterrupted. But I can get back to you. I'm not as familiar right now as what the county is doing in the Trappers Point bottleneck right now.
Okay, and then another question that we received, is there any discussion about sage grouse wintering area on NPL?
Yeah, there's been a fair amount of sage grouse work in the region. I know there's some data from the NPL region, but I'm not sure what the conversations are ongoing right now with sage grouse. I know there's been a lot of discussion about noise disturbance, in particular with sage grouse and their lekking. In the Jonah in particular, again, the Jonah infill project is much higher density of well pads and roads compared to most of the Papa. I'm not sure the MPL expansion per se, but I know that sage grouse are in the conversation. What those conversations are, I'm a little outside the sage grouse realm.
Great. Thanks, John. And that looks like that's our last question in the question box. And I know you have an appointment directly following this webinar. So if you do have additional questions, feel free to respond to the email invite to this webinar and we can connect with John on those. As always, all of our webinars are recorded, and so you can find this webinar as well as all of our previous ones on our internal toolkit as well as on that external site that I mentioned at the beginning. Both of those links were in the chat box to start. Our next webinar is scheduled for September 12th at noon Pacific, 3 Eastern, and we'll be focusing on the California Stewardship Landscape Network, which is a new network that's bringing people from across the state of California together to work on connectivity issues. So feel free to sign up for those and all future webinars on both of those websites that we mentioned as well. John, on behalf of the National Park Service, thank you so much for all the work that you're doing, and thanks for being willing to present today. It was really, again, an inspiring webinar. Thank you.
Well, thank you for the invitation. I appreciate it.
Okay, take care, everyone. Enjoy the rest of your day.
Thank you. You too.
Bye-bye.
Bye.